slides. We'll cover the rest of the Friday slides on a future day here. Okay, but here is, I thought maybe we'll work through certain concepts that I want you to learn, and that will, I think, also help you with your homework. And I thought I would do it by doing kind of this live coding thing. And if you want to follow along, you can follow along. If you just want to sit and watch and hear me talk, also great. So anyway, I've started up RStudio, and I'm going to work with this data set called Gapminder. I don't know if anybody did the data camp homework that I assigned just like a couple days ago. Some of it, some of it not. Okay, they use a data set called Gapminder, and we're going to use the same data set, doing some similar stuff here. Okay, so if you want to run Gapminder on your computer, you first have to install the Gapminder package, okay? Now, remember, there is a difference. So the analogy that I think works is when you do something called install.packages, okay? You can think of packages as kind of like cookbooks, all right? Cookbooks with recipes and stuff, okay? And if you want this on your bookshelf, you have to purchase it, right? You got to go to the bookstore and you got to purchase this thing. So install.packages is kind of like purchasing the cookbook and putting it on your bookshelf, right? So the first thing we need to do is we gotta get this package. So we're gonna do install.packages Gapminder. You put the name of the package in quotes, all right? And the function name is install.packages. You put that inside parentheses. And I already have it installed. So sure, I'll just go ahead and restart and install it. And you'll probably see some stuff fly by, and it downloads, and it says, what you want to see at the bottom, okay, is package Gapminder successfully unpacked and checked, and all of this, okay? Red text is not necessarily bad. Red just means pay attention to this, okay? A lot of times we associate red text with errors, and it is true, errors do show up as red text, but red text doesn't necessarily mean something went wrong either, okay? Yeah, question.
Sorry, so when I do the install packages, I get the script that says the download binary packages are in, but I don't get the successfully unpacked.
Okay, you're probably fine. Here, we'll check to see if it worked, okay? And we would run library Gapminder to see if it gets worked. So right now I just ran this in the console, okay? Now, so this is like purchasing the book. Anytime you want to like use a recipe from the book though, from the cookbook, what do you have to do? You have to pull it off the bookshelf, okay? So to do that, the command to say pull the book from the bookshelf is called library, all right? So anytime you call library, you're going to basically open up that book. But you don't need to run install.packages, right? Once you buy the book, you don't have to buy it again every single time you want to make a recipe, all right? So buy it once, install it once, and then anytime you want to read it, you got to call library. So if you do want to read it, you got to call library. Now, sometimes they do update the packages, right? Just like they update, third edition of chemistry, whatever, and it's like another $190, and you say, I got to do this because the textbook problems don't line up, or I don't know, whatever. Okay. So anyway, for our class, I'm going to work through an R Markdown document, and I hope all of you have tried like knitting and all of this stuff, and you got your homework 1. Problems 1 and 2, knitting. Okay, so here I'm going to just do a new blank R Markdown document. This is what you would do to create a thing. And I'm going to go to PDF. Now, if you want HTML, that's fine, or Word, that's also fine. But I'm going to go to PDF, and I'll just call this Week 2 Monday. All right. All right, and so when I do this, it pre-populates with stuff. This is an R Markdown document. And I always like to just click knit right here. And let me save this in the folder. I'm going to save this in my Stats 15 folder. Lectures under Week 2. And I'll call this, what is this? Stats 15. Lecture Week 2, Lecture 1. All right, and this is going to be called in-class demo. All right, so I like to just knit just to kind of make sure everything's working. And this is all of the pre-populated stuff. This has it just says, this is an R Markdown document, including plots, etc. And I don't actually want any of that. So I'm going to just, so once it successfully knits, I'm going to just go ahead and delete everything in my document, other than the header. Maybe I'll move my face over here. Okay, so I'm going to just go ahead and delete everything. Okay, so let's get started with this. And I'm going to insert a code chunk. I like to use the keyboard shortcut, Control-Alt-I on the PC. I think it's Command-Option-I on Mac, right? I'm not 100% sure. You can always kind of hover over this +C to see what the code chunk is, keyboard shortcut is. And it's going to pop up here. You're going to get triple ticks, curly brace R, and this basically says, the code inside here is going to be R. Now, you can, R Markdown, RStudio, they've integrated Python and stuff, and if you learn Python later, you can actually integrate Python code, and you just kind of, you replace the R with Python, and this lets the computer know that this code chunk contains Python code instead of R, and things like that. And there's a few other things you got to install, like additional packages, reticulate, and things. But, well, anyway, just so you know. Okay. Yeah, question before.
Would you hand off information between languages, or would you have to write it into CSV and then pull it off?
No, yeah. So the package reticulate allows you to kind of hand off variable names and values from from R to Python and back and forth. But you kind of it creates this and stuff. So it's very cool. It's very cool, but beyond the scope of our course right now. Okay. We can't learn how to fly the airplane until we learn basic driving things. Okay. All right. So here I'm going to load up Gapminder. I'm going to just call it library Gapminder. And again, library is basically, hey, grab this book off of your bookshelf. You've already installed it. You've already have it. Okay. And then we're going to call library Gapminder, and then I'm going to load up the Gapminder data by saying data Gapminder.
So for baby names, you would do the same thing?
Yes, for baby names, you would do the same thing. You would install your baby names package one time, not inside your document, okay? Because the document is basically like instructions on how to do this. And so when you say okay, I'm going to give you instructions on how to set up Thanksgiving dinner, you're just going to say you need to have what? Joy of cooking, and you're going to look up the turkey recipe and the mashed potatoes recipe or something, right? But in your instructions, there's kind of already an implicit assumption that they already own the cookbook. And you're not going to say, okay, every time you want to make turkey dinner, you've got to repurchase this cookbook, okay? So we're going to just call library and data, and we can run it, okay? And we'll just run this right here. I get a warning. Okay, so my R is version 4.2.0. So I probably need to update in the next couple of days here, but I'm not too concerned at the moment, okay? And, I click play, and at least I didn't get any errors. I got a warning that my R is a little bit older, but no errors. So this is a good sign. If you're encountering errors here, then either you haven't installed your package, or you typed something in wrong, or something. Okay, so let's take a look. Let's take a look at the Gapminder data, okay? So one thing you can do is you can go over to your environment and you can just click Gapminder. Another thing I like to do is I like to ask for either the structure, or you can also ask for a glimpse, okay? We are going to make use of two packages called dplyr, and this allows us to kind of filter and sort and arrange our data, and then we're also going to use ggplot to make our plots, okay? So I'm going to call library dplyr and library ggplot2. ggplot2 is the name of the package. So I'm going to just load up these libraries as well. Now, if you try to click play here or run the code, and you encounter an error that says dplyr package not found, or ggplot2 package not found, or something, then again, that means you have to purchase those cookbooks, all right? And so you'll go into the console and you'll do install.packages in quotes dplyr, install.packages in quotes ggplot2 if you're encountering any of those error messages. Otherwise, it should run. Here we get like just a message. This isn't even a warning. It just says, hey, you know what? This is happening, okay? And all this is basically saying is that, you know, base R has certain functions called filter and lag. And, you know, when you loaded this library dplyr, there's also a thing called filter and lag. And because you loaded this, we're going to use that one instead. So it's kind of like, you know, you already have a mashed potatoes recipe, but you bought a cookbook that also contains a mashed potatoes recipe. So when somebody says, I want the mashed potatoes recipe, which one are you going to do? Now it's saying we're going to default to the one in the cookbook that you just loaded, okay? And stuff like that. Okay, question.
So you can't, in your document, you can't install the package. It always needs to be in the console.
Yeah, you don't want to install your package in the document. Yeah, I mean, I wouldn't say you can't. It's allowed, but it will severely hinder your code, and you should never do this. Okay, so it's not that it will break your computer, but it's just you should never do it. It's basically saying anytime you want to make mashed potatoes, you have to repurchase this textbook or repurchase the cookbook, and we don't want to do that. We just want to say buy it once and then just open it up. Yeah, question?
To run it, it says that there's an error because there's an attempt to use a zero-length variable name.
Zero-length variable name? So you're calling library dplyr? Where are you getting the error message?
For both of them, you got Minder
and you've already done install.packages?
Yeah.
You've done install.packages and you're getting the thing on library. Are you putting these in quotes or no quotes?
It's exactly like that.
It's exactly like this? Okay, I'm gonna have to take a look in a moment, all right? But or during office hours. Okay, more questions. I want to keep going because we haven't even done anything.
Super fast.
Okay.
Is there a particular reason why you didn't include the calling ggplot and dplyr in the same code chunk as Ggplot?
No.
Okay.
I'm just breaking the things up across. Okay, so let's go ahead and let's take a look. Okay. At our thing. So one thing I'm going to do is I'm going to call str structure, okay? str gapminder, and we can just see what the data looks like, okay? And it says what we see here is there's 1,704 rows and there's 6 columns, and the names of each of those columns, we have country, we have continent, year, life expectancy, population, and GDP per capita, okay? The full Gapminder data set actually has a lot more variables, but this is good, okay? This is good, and it's enough for us to do some basic stuff here, okay? So let's say we wanted to create a plot. Okay, so we're gonna do I'm gonna call this task 1, all right? So we're going to create a plot for the United States. Okay, create a plot for the United States. Okay, and what we want is let's see, the United States. How has GDP per capita, or let's just say how has population changed over time? Okay. Okay, so let's think about this. If I wanted to make this plot, so this is very important, okay? We have to think about what are the variables we need, and what is our unit, okay? And what am I gonna have? So let's think about the variables. Okay, so in my plot, along the x-axis, what should I put? Huh? Time, okay, but I don't have a time variable here, right? So we're looking at our data set, and what do I need to do? Yeah. Year. We're gonna put year on the x-axis, okay? What am I gonna put on the y-axis? Population. Okay. Is there anything else I need to do? Okay. Country. Now, how do I do this with the country?
Colors, different colors maybe? Shape.
So, okay, if I say ggplot x-axis year, y-axis population, okay, because we can do that. What kind of plot will I get?
It's gonna do everything.
Well, let's say I do geom points. So let's say I add points here. Well, yeah,
Would you need a subset for intelligence?
yeah, we would need to, so if I do this, I would get 1,704 dots in my thing, okay? So I'm gonna insert a code chunk, and I'm gonna just write, I'm gonna put a comment, and this will be not correct, just so you can see what will happen, okay? Not correct, and this will have too many data points. All right, so to create, we're gonna do ggplot. What is the data we're gonna use? We're gonna use Gapminder, okay? And our mapping, we're gonna write AES, and we'll do X is year, Y equals pop, okay? And then we're gonna say geom_point. Just so you can see what's gonna happen here, all right? And if I click play here, it's kind of hard to tell, but we have a whole bunch of dots here, and this is what's going on. This shows basically all of the countries, and this is not what we want. We want to look at the United States. Okay. What are we seeing here? Just here. What do you think? What is this? This is population of China. What's this? India, and then this would be the United States. The United States generally third in population over. Okay, so we have too many data points. Okay, this is everybody. So what we need to do is what we're going to do filter, and we want to find just the country, the United States. Okay, now the United States is one of those things where it's like, how is it stored? Is it US? Is it USA? Is it United States? There's all kinds of, right? So our data set has 142 out of, I don't know how many nations, 200-ish, depending on who you ask. But okay, so how do we find what our things are? So we're gonna ask, okay, let's just take a look at country. Now, if I ask the country, if I just do Gapminder country, okay, to get the country column, I can just type in country. Now, if I do this, how many values will it print out? Yeah.
What about 140 something you said?
No, it will print out 1,704, all right? It's gonna print out the entire column, okay? So I'm gonna do this, but this is gonna be like, this will print out all 1,704 values, which is, too much. Okay, so if I do this, it will give everything, right? And because we got Afghanistan, Albania, Algeria, right? So this is too much. So better. Okay, so don't do this. So I'm going to write. So instead, we can just ask, okay, what are the levels? What are the unique values? If you have something called a factor, you can ask for levels, or you can also just ask unique. All right, so here I'm going to just do levels, and now we get 142 values. And we can see, okay, it's called United States, all right? Not USA or US or whatever, it's just United States. So this is the names of all the countries that appear, right? Which is useful. I mean, some places, like, there's no ambiguity about, like, what the name of the country is, all right? But other places, right, like you have Yemen, Republic dot or something like that. So this will be important. So all right. So the first thing that we're actually going to do here is we're going to take. I'm going to insert another code chunk, and what we want to do is we want to just find the rows associated with the United States. Okay. So I'm going to start with Gapminder. And I'm going to insert this sign here, okay? This is percent greater than percent. This is known as a pipe, okay? And this allows you to kind of chain a sequence of events, all right, or a sequence of commands. And so we're gonna just start with like, look at Gapminder and take this, and I want you to do a function with it, okay? And then if you do something, you can do like another function after that. And it just kind of says like, okay, we're gonna do a sequence of these things. So what I wanna do here is I'm going to filter. And we only want the rows. We have, 1,700 rows. I really only want the rows where country, and again, let's, here, I'm gonna shrink this so I don't have to, it doesn't eat up my space. We're gonna do country, and we want country to be United States, okay? So country equals, quote, United States, all right?
You only
And
type one single equal sign.
you need to have two equals for filtering, okay? Single equals is used for assignment, same as the kind of the arrow. It's basically you're trying to assign a value to it, and you're going to get a thing. So you need to have equals. So this is going to filter our data just down to this. And I'm going to just go ahead and click play here, just so you can see what happens. And you can see we get a tibble, and now we only have 12 rows, okay? We have data from 1952, 1957, 1962, basically every 5 years until we get to from 1997, 2002, 2007, okay? So not the most updated of data sets, but we have 12 rows here, okay? All right, and so now I want to take this and I want to create a plot. And so what am I going to do? I'm going to do Ggplot. And so here's the thing, when you pipe it, so normally when we created the Ggplot, we had to say what is the data set we're using. When I pipe it, it's going to say, okay, we're going to take this data set, which only has 12 rows, and we're going to create a Ggplot based on this data set with only 12 rows. All right, and then so I don't need to specify the data set, but I do need to specify my mapping. So I'm going to write AES, and what will I do? X equals year, Y equals pop, and let's add geom underscore point. Oops, and I misspelled geom point, so that didn't work. All right, and there you go. So there is our map of the United States population over time here, starting in 1950 to, and we see, fairly linear growth actually over the past, I guess, 60 years or so. Okay, question.
You know what the error in fortify means?
I don't.
Yeah.
Okay.
So data must be a data frame or other object coercible by fortify.
Okay. I imagine we did something wrong with our filter or something.
You don't have the other pipe. You need another pipe also.
Oh.
Okay. All right.
After United States, put another pipe.
Okay.
What's the point of you putting levels just so you can see how United States would
Yeah. The point of this thing with the levels was to see how is what is the name? What do we call the country? All right. So what is the name of the United States? Is it USA or US? Okay. So this will do this, and so you don't actually need to run this. So I'm going to just do eval equals false up here, and this way it doesn't get run. And then also not correct, so I'm going to just eval equals false over here, so it doesn't get run. But you can run these yourself just to kind of take a look. All right, so this is our basic plot here. Okay, what if what if we wanted to compare the populations of the United States and China? compare the populations of the United States and China. All right, so this time we'll start with our Gapminder data, and I want to filter, and I want to filter down to 2 countries. We'll compare the United States and China, okay? So this time I'm going to do country, and I want the country to be either the United States or China, okay? And so to do this, I'm going to use a command called in, and I think I want to make sure I do this correctly. All right, and so I'm going to do filter. Country is either in this vector. All right, and then anytime you do kind of a filtering operation, you should just kind of check to make sure it does what you want it to do. And so I click it and I get China, and I can kind of filter, like look through this, and this looks correct, right? This looks like it did what I want to do, because when I filtered to only the United States, I only had 12, and now that I'm filtering to 2 countries, I have 24 rows. So this seems correct, right? All right, is that okay? So this is, so you don't want to do, okay, so this is a mistake. Don't do this. Country equals China or United States. That's not going to work, okay? You want to say the country name is either in China, United States. If you wanted to do like more, you can do United States, China, India, or whatever, okay? But here I'm just going to compare these 2, all right?
What's that in percentage called?
That's just a command for, it's the in operator to see if the thing you're looking for is within one of these values. Okay, we had a question back there first. Yeah.
Yeah. So if you put the United States before China,
It doesn't matter. The order in which you do this doesn't matter. So
why does China come up first then in the output?
because C comes before U in the alphabet.
Oh.
Okay, and I mean, well, technically it's because in the data, China was listed before the United States in the data. Okay, it's gonna filter in the order that it appears in the data, and the data was arranged alphabetically by country name. Yeah.
Why didn't we put a pipe like to the right of this screen?
We will when we want to create a plot. Okay,
Oh.
we will when we want to create a plot. Yeah.
Is R indent sensitive?
It is not, but it makes it easier. Okay, it's not like Python. Yeah. Percent in percent is just it's just an operator that just checks to see, and you use it in things like filter, where you want to like check if you want to kind of filter down to like one of multiple values, right? So if you want to say like, okay, I want either China or the United States or India or whatever, you create basically a little vector with basically the options that you're looking for or the values you're looking for, and you can do percent in percent, and it's going to basically filter down to those things. So it does exactly what you're seeing here. Yes?
Can you explain the percent and the percent?
This is called a pipe. Okay? This is called a pipe, and basically we start off with the Gapminder, and we're going to do an operation to it, and it allows us to kind of chain operations. If you don't use the pipe, you have to say, okay, start off with Gapminder, do this operation, and then I want to use these results, so I've got to store these results somewhere. And then take that object that I've stored, and then do this operation. I want to use those results in the future, so I've got to store them somewhere else. Okay? Pipes just say, hey, you know what? Let's not put these things into storage every single time. Let's just take this, and then let's just hand it right off to the next operation without having to store things in between.
Is it kind of like if in Python we do like Gapminder, Gapfilter, and the next thing?
Not quite, but yes. If in Python, if you use a dot operator, it returns an object of itself, and you can chain operations that way. But it's a little bit different. But I don't want to talk about Python. Okay, I love Python, but that's not the focus of the class, and I'm afraid we will get distracted with
outside of the scope.
Yeah, non-relevant things here. Okay. Okay, so I've done this. I'm going to go ahead and chain another operation, and let's go ahead and do a ggplot here. Okay. So
Shortcut for that? The pipe operator?
Command Shift M or Control Shift M. Okay, so I've got ggplot, and we're going to just take the results of this 24 by 6 thing, and let's go ahead and put X on the year. Y will be population. Now, how am I going to distinguish between the China and the United States, the two countries? If I did this, I'll just have 24 points. What should I do?
You can do country equal, color equals country.
Yeah, okay, so let's go ahead and do color equals country. Is that all right? And then we're going to do plus geom underscore point. And we'll go ahead and click play, all right? And so here I've got China, I've got the United States, okay? Does that feel okay? All right, and perhaps to kind of show, a lot of times if you want to show like changes over time, instead of geom point, you can do geom line, and now you get lines instead of like the points get connected with the line. I don't know, okay? Well, whatever you want to do, okay? All right. Does this feel okay? So now here's a question. Which one grew more relative, proportionally? China? Do we know that? How do we know that? Are we just eyeballing that? Huh?
Can we scale it or something?
Yeah, so what do we need? What if we wanted to do like, okay, let's take the population that they were in 1952, set that as a baseline, and which one grew, over time, which one grew more? Okay, how would we start to answer this? So what would we need on the y-axis? Yeah.
Would you do a logarithmic scale?
The logarithmic scale could help. I mean, we can do that, but I don't think that enough is going to answer our question. What would we be looking for in a logarithmic scale? So I could do like plus scale y log 10 or something like that. Okay, and so this puts it on a log scale, and I don't know if that helps. I mean, now it's like 300, 500 million, 1 billion and stuff. So I don't think this basically we need to create a new variable, right? So let's say I'm going to write, so which country grew more in relative population? Oh, you know what? I got to give you view quiz answers here. I forgot what the answers were. Let me look this up. Okay, so think about this. Talk to your neighbors while I'm looking up your view quiz answers. And think about, what do we need to do? Like, not in the computer, but if you just had to, right, if I just gave you this table with, where we filtered down to these two countries, okay? So starting with this as a starting point, what is the next thing you would need to do, right? Like if you were just given this data in, say, Excel, what operation would you do, all right? Because if I just do y equals population, this is what it looks like. But we don't want that, right? So we're gonna, what I want is 1952, we're gonna start off at like 1. And then, if the population of China is twice as big in 2007, then it would be a line that goes from 1 to 2. And for the United States, I don't know what this is. And if it doubled in size, it would go to 2. If it tripled in size, it would go up to 3. If it only went 1.5 in size, it would go to 1.5. Okay? So talk to your neighbor and think about how are we going to calculate this? And what would we do? Okay? Okay, all right, let me get your attention back. All right, let me get your attention back. Okay, so before I go on and before I forget, your first view quiz answer, let me go ahead and give you your first two. The first one is C as in cat, and the second is B as in bear. C as in cat, B as in bear. Or Bruin. Or bat. Or ball. I don't know, whatever. Okay. There's a bunch of words we can list that start with B. But C as in cat for the first one, B as in bear for the second one. Okay. So what do we decide to do? Yeah.
The population of each year divided by the original population in 1952.
Okay, but in China, we have a different number for 1952. And in the United States, we have a different number for 1952. So we also have to keep that in mind, right? So I can't just do population divided by 150, what is this? 157 million, okay? Or I can't do population divided by 556 million. I have to do only for China, divide by 556 million, only for the United States, divide by 157 million, and something like that, okay? So the operation gets a little bit complicated, all right? So we could do this in one thing. It's going to be, it might be a little bit advanced right now to introduce it right now, but if you're not sure, start off very basic, okay? And you can just start by saying, okay, well, first, let's just copy and paste this number, right? In the beginning, if you're not sure, just start by like writing down the number, and then if you're like comfortable with the idea, then you can make it a little more advanced, right? So one thing, okay, is I can take this result, okay, and I'm going to create a new variable using something called mutate, right? And then we'll do, and this one will be relative change for China, okay? And here I'm going to do population divided by, I'm going to just take this number, 556. So this will be how has the population relative change for China. And I'll go ahead and just click play to see like, okay, did this work? And I kind of have to scroll over here, all right? So 1952 starts off at 1.0, and then by the time we get to 2007, we're at 2.37. Okay, so that sounds about right, okay? But then we also need it for the United States, and the United States is going to be something different, right? So I can do relative change US, and this will be, I'm going to just put it on a second line, so make sure you put a comma in between things. So here I'm like creating more than one variable, and we're going to do population, and I'm going to divide by this, okay? So we've got two different numbers here, and right now we're not going to be able to plot this because we have two columns, and when you plot something, you want everything in one column, okay? So for relative change to the US, we look at 1952, we start at 1.0, and then in 2007, we end up at 1.9, okay? So from 1952 to 2007, the U.S. almost doubled in size. It went from, it grew like 90% from 1 to 1.9, and then China went from 1 to 2.37. Okay, so so that does kind of answer a question, but it doesn't. We're not able to plot this right now. Okay, so this is kind of like a rudimentary way to do it. Okay, because ideally we we don't want to have to like hard code these values in the first place. Okay. But let's just start here, and basically what I want to do next is we're going to just take these two columns, relative change China, relative change US, and let's see if we can combine them into one. Okay, and we want these values for the first 12, or basically the ones where it's China, and then we want the other values when it's the US. Okay, so I'm going to create, so after I've created this operation, I'm going to create another column. I'm going to use mutate. Well, so I want to kind of pause and just make sure everybody's okay with this so far. All right, okay, and then we'll just do relative change 1952. And we need to get both of these into one, and we have a condition, okay? So, how should we do this? Okay, well, one possible operation is I can do an if-else. This only works if there's two. If you had like multiple, it gets a lot harder, but I'm gonna just do if-else, okay? And this if-else is, I hope this works. Country, if country is China, we want, oh, you know what? I don't think this is gonna work.
Let's try it. Wait, what's the format? If test.
If else.
No, where? X would be divided by this.
I think. Okay, don't copy this. All right, all right. Okay, I'm going to try this out. Right. So there's did this work? 1.0. Oh, it actually did work. It did work. Okay, I was afraid it wasn't going to work.
Copy this.
But I guess you can copy this. All right. So here, basically, I said if the country is equal to China, then copy the column from relative change China, and if it's not equal to China, then copy from the other column. Right. And so this is one way to do it. And now we have the values that we want. So in 1952, we're starting off at 1.0, and we end up at 2.237, and then in 1952, we start at 1.0, and then we end up at 1.91. And so we can kind of see how things have changed. So that works. And if I want to create a plot, then I'll do ggplot AES. X is equal to year, Y is equal to relative change 1952, color is equal to country, and then we'll add geom underscore point. And there we go. So they both start here, and then this is kind of the relative change since 1952 that we've observed as far as population goes. Okay, so that's But this is not going to work if we wanted to do like China, United States, and India. All right, so we wanted to kind of scale things up. So I guess, well, I think this will be enough for you to start doing exercises, parts 3 and so on in your homework, right? You've got kind of a filter. The other part, well, I'll also do your, I guess, data camp homework. The data camp will mention things like a range, okay? Which will allow you to kind of sort things by value and stuff, which you can play. So I think your first data camp homework will have filter and mutate, which we've seen here. It'll also bring in a range. And then we'll, I'll show you a preview of like where we're gonna go next. Yeah, we have a question.
If you try to do it with like 3 countries, you should do it if else and not another if else.
Yes, so you can embed a bunch of if else's within each other. So you can do if else, and if it's China, then do China. And if it's not, then do another if else. And if it's United States, then do United States. And if it's not, then use India if you have 3 things. Or you could do another if else. And you can have a whole chain of if else's. But it becomes unsustainable or doesn't scale up very well. And so so in the future, okay, we're going to learn kind of this group by operation. And, don't... So I'm going to do group by country, and then I'm going to say mutate. You don't have to do this, so I'm going to call this relative change. And this will be, we're going to do population divided by, and then I'm going to do, what do I want to do? I was going to do min, but 1952 is not necessarily the minimum value. So let me just test something out over here. Group by country, and what do I want to do? I want to do filter. Year equals 1952, and we're going to pull pop. I think this is what we want. Is this going to work? No, that didn't like it. All right. Well, okay, so let me do filter country equals, or not equals, percent in percent, China, United States. Okay, so this is not population min of population, and I think this will get it, but that's only because country 1952 was the minimum value for both of these countries, and if I wanted to scale this up something larger. But here I'm saying for each country, okay, start off with the population, divide by the minimum population that they see. All right, and so over here, relative change, I've got 1, and then for the United States. And this will scale up, and I could put in multiple countries, so I can do India and Canada, and we can see, which of these things. So Canada grew to 2.25, China grew to 2.37, in India 2.98, almost tripled in size. India, United States grew 1.9, and things like that. So, but this is where we're headed. Don't worry about this whole group by and business just at the moment. Yeah.
So the problem with this is that if a country like decreased in population.
Yeah. So so the problem with this solution right now is it's assuming 1952 is the lowest population in our data set. So if a country had like 1952 had a population and then declined to 1957, this would be wrong. So I have to think a little bit more, and so there's some problem solving that you got to kind of think about. Let me give you your last view quiz answer because it's already 9:50. The last view quiz answer today is the letter E. E as in elephant. E as in elephant. Okay, and we have another question.
What's the difference between mutate and just defining a variable?
You mean just like creating a new vector?
Yeah, like why do we use mutate rel change equals instead of just rel change and then assign that something?
So mutate works with the pipe. So mutate when you're handing off something, you'll use mutate, and it basically keeps all of the current columns, and then it tacks on whatever new column that you've defined.
I see.
Yeah. Okay. Last two questions, and then you guys got to go. Yeah.
What would be the difference between mutate and cbind?
Mutate and cbind, they're very similar. Cbind, yeah, basically binds a new column that you just have to define a separate vector entirely. But they are similar in operation as far as what we're doing here. Okay, we'll end here. Hopefully you can at least get started on some of these problems in the homework. And we'll see you on Wednesday. If you have more questions, come to office hours then.
Which one of the app this is going to be posted?